All right, so now let's use what we just did and work with the three different representations we have to answer the questions below. So this says, first of all, to identify the slope of f of x. Well, we've already done that in the equation. We can see that from the graph, negative 5 over 4. We can see it from the equation, negative 5 over 4. And if we use the slope formula over here in the table, we could also get the slope from that. So remember that slope is found by doing y minus y over x minus x. So if we picked any 2 points here, let's say I picked those 2 points that are highlighted, that would be the point negative 6, 8 and negative 2, 3. If I plugged those into my slope formula and did 8 minus 3 over negative 6 minus negative 2, that would be 5 over negative 4, which is negative 5/4. Now this does say on the table, show why this is the slope no matter what 2 points are used. Well, if I look at the table and I figure out what my change in y is each time, right here, from when I go from 8 to 3, my change in y is a negative 5. And when I go from negative 6 to negative 2, I just went a positive 4. And when I go over here on the y from 3 to negative 2, that's a change of negative 5. And over here it's a change of 4, right? So if I divide out my actual slope down here, my actual slope, negative 5 divided by 4 is negative 1.25, right? Negative 5 divided by 4, negative 1.25. Negative 5 divided by 4, negative 1.25. And it just keeps going, no matter what 2 points we use. Here we're just going down 2.5 to 2. But if you divided that out, if you did negative 2.5 over 2, you would still get negative 1.25. Okay? All right. Identify left-in behavior. That's what we just talked about. Left-in behavior is the behavior as x heads out to really small values to negative infinity. So as we go out to the left on this function, what are my y values doing? They just keep going up forever and ever and ever. So let's back out of there. So y is going to head to positive infinity. And on the right end, as x approaches positive infinity, y is heading to negative infinity. As we go out to the right, as the x values get larger and larger and larger as coordinate pairs, as the x's get larger, the y's are getting more and more negative. This is between which two x values in the table, so this is asking us to look in the table, does the zero of the function lie? So remember, in a continuous function, we look at our table and we say, well, how do we know that the y value went through 0? And we can tell that right here, the y value has to go through 0 because the y is going from positive 3 to negative 2. So the x values that correspond to that are negative 2 and positive 2. So we know that somewhere between x equals negative 2 and positive 2, f of x equals 0 because f of x changes from positive 3 to negative 2. And we're going to say it just like that, okay? So we would say between x equals negative 2 and x equals positive 2 because the y goes from equaling, what was it, 3 to negative 2, and therefore must go through 0. Okay, very good. We can double check that and see on the graph, where does this equal 0? Right here. Well, if we look at our graph, f of x equals 0 right there. That is definitely between negative 2 and positive 2. All right, let's keep going. Use the function of f of x to actually find what the 0 is. So now it wants us to use the equation. Okay, use the equation of f of x, not the table. So we know f of x equals negative 5/4 x plus 1/2. We want to know when that is 0, so we're just going to make that equal to 0. That's what a 0 is when f of x equals 0. And now we're going to solve it. we're going to subtract 1/2 from both sides. So that leaves us with negative 1/2 equals negative 5/4 x. And then we can multiply each side by negative 4/5. Okay. And those over here cancel. And we get x equals, x equals 4/10. Or 2/5, however you want to do it. Okay. Identify the intervals. I'm going to do this as 2/5. So that's when y equals 0. That is the x value of that coordinate right there. That's the point 2/5, 0. Do that in a little bit nicer. All right, very good. So now we know that's where it's 0. The next question says, identify the intervals where f of x is greater than 0. Well, we need to know how to do this on a graph. We're just looking for where the function is above the x-axis. So the function is above the x-axis for this whole part, which means it's above the x-axis from negative infinity until we get to 2/5, because it's an x value. So from negative infinity to 2/5, but doesn't include 2/5 because it's got to be above 0. And then it's lower below the x-axis when we go from 2/5 on to positive infinity. So 2/5 to positive infinity.